Hello, my name is Daniel Allen. This is Lab 4. In Lab 4, we've built a complete microprocessor, which basically just controls the brainless CPU that we built in the last lab. Um, we also, in this lab, um, created a couple other modules, which I'll show you, and then um, implemented 4 new instructions which are and, zero, sub, and store accumulator. So let me show you how this all works. First, we're going to start with these are the 3 main modules. We're going to start with the controller module. The controller module contains the 4-bit instruction register um, that holds the current opcode, uh, the 2-bit step register, which tracks which micro operation that we're currently executing, and it contains this ROM, which basically stores all of that microcode. The ROM also then outputs a 10-bit control bus, which drives the entire processor. The address generator is responsible for managing the memory addresses. It includes the program counter, which we built in one of the last labs, which increments through sequential addresses. It also includes this MAR, which stands for Memory Address Register, which allows us to access arbitrary memory locations. The multiplexer then selects between PC and MAR to drive the address bus. And then finally, we have the brainless CPU, which we built last lab, so I don't need to show this off, but all of these are now driving the brainless CPU, right? So the controller splits off into the brainless and also the address generator and itself. So it's that's sort of controlling everything. The um, so the 3 instructions that were provided are load accumulator, add accumulator, and stop. And those are all just, you can see them right here, right? So if I clock once, twice, that's it's loading, right? Clock 1 loads it, um, and then clock 2 adds it, and then 3 and 4, same thing, and then it calls the stop. So now we're stopped, but we can still reset and then do it again. Um, and then the 4 new instructions, which I talked about earlier, are and, zero, sub, which subtracts, and store accumulator, and those 4 I've implemented into this one GTK wave simulation here. So I'm going to show these off. We're going to go 1 clock at a time, right? So start at clock 0. So at clock 0, we reset the circuit. You can see reset is high here. Clock 1, we are going to load the instruction, or we're going to load the load instruction, which is opcode 0, into the instruction register. Clock 2 then loads the value 7 into the accumulator. So you can see accumulator is now at 7. Clock 3, we fetch the AND instruction, which is opcode 3, which you can see in the instruction register. And then clock 4, we AND the accumulator with 5 in the ALU out, and 7, which is 0, 1, 1, 1, and 5, which is 0, 1, 0, 1. ANDing them together equals 0, 1, 0, 1, which is just 5. And so that is why the accumulator is now 5. Clock 5, we are going to fetch the sub or subtract instruction, which is opcode 5. And clock 6, we then subtract 2 in the ALU out from 5 in the accumulator, and this just equals 3. So the accumulator is now 3. Clock 7, we fetch the store accumulator instruction, which is opcode 6. And clock 8, we store, then store accumulator, then reads the target address F, which is the address 15. Right, so down here I have it written in my notes that store accumulator, we're going to store the accumulator value of 3 into address bus 15, or address bus F. Um, and so you can see right here that like the MAR um, goes to F, right? So we're reading the target address F into the memory address register. And then clock 9 writes the accumulator value to RAM. So you can see the write signal goes high, and the value 3 is then written into address 15 right here. And right, so we're accessing address bus 15 here, and the address is 3. Or address bus 15 and the value is 3. Then we fetch we're gonna fetch the 0 instruction, which is opcode 4, and 0 then clears the accumulator. So you see here the accumulator then becomes 0, and then we fetch the stop instruction. And clock 13, very final clock, we enter the stop loop where the processor finally halts uh, with the done signal being high. And that is basically everything. That is all 4 instructions working properly. That is showing off each of the things that we've built. I mean, there are the right, the 2-bit register, and which is just based off the 4-bit register, and the 2-bit bus mux, which is just a very simple circuit. All of those that we've built this lab. Um, but yeah, that's basically everything that needs to be um, displayed. So yeah, great. Lab 4 done.